Did I do that really? Shoot. All right. All right, so the first few, let's see. Well, the very first one, hopefully, you kind of teased out what that was asking you from context. The scale factor, I think it was. What do you think that references, scale factor? Yeah, just the multiplier, right? So if it's scaled down, it'll be a number less than 1. If it's scaled up, it'll... So you can actually go either way, because it didn't say a scale factor from one to the other. Which triangle is bigger? Yeah, triangle ABC. It's got the longer side that's corresponding to the other side. So me, I would always kind of like default to, if it doesn't matter for the problem, I would default to giving the multiplier up. So how do you determine how much bigger? What's the scale factor? What's the multiplier to go from XYZ to ABC? What would you multiply, or just what ratio do you make between the two? So like these two are kind of corresponding sides between the two, yes? So then when you set up the ratio, you get AB to XY, 6 to 4, 3/2. So triangle, man, my favorite pair of glasses. Triangle ABC is 3/2 times XYZ. So it's 1.5 times as big. Okay. Is that okay? So scale factor, I didn't say those words, but you all know the word scale. 1/4 scale, 1/10 scale. It's just the multiplier you use to get from one thing to the other. If you said 2/3, you're fine, because it didn't say which way to go. So you could say ABC is, XYZ is 2/3 ABC. Number 3, and I really enjoy these where number 2 is just sort of not here, but that's okay. This is kind of a silly question. What do you guys pick up on immediately about this question that's sort of silly? So we got two similar triangles. Part of this is correct, yes? Are the corresponding angles congruent between two similar triangles? Hell yeah, it's got it. It's like that's the most fundamental definition of similar triangles. Their angles are congruent. But the other part of this, are the corresponding sides congruent? Necessarily, no. So that's the part that's really just silly. If I have similar triangles, obviously the sides can't be congruent, or else I just call it a congruent triangle. So is it always true? No. So I would say, no, I can't assume. Could it be true? Hell yes, because congruent is just a very specific type of similar. Where what would the scale factor be between two congruent triangles? 1, yeah, 1 is 1 times the other one. Okay, look at number 4. What do you guys think about this? This one's pretty, this one's almost insulting your intelligence a little bit. I mean, what do you guys think about those? I mean, 72 is good, but the only way this could be saved, could somebody tell me if I left, so here's a better question. If I left C, D, E alone, besides 39, what could angle F be? To make these similar. So let's say I'm not going to make that this. And I'm not going to make it 39 either. 39 would be too easy of an answer. Why 69?
I'm sorry.
You're good.
The other triangle, 72 plus 39 plus 69.
Beautiful. So then it would be similar, and somebody just kind of rotated it around like that. Beautiful. You guys kind of with me? So real quick, if they give me two angles and they're not congruent, that doesn't mean the triangles are not similar, because they could have given me the alternating pair of angles. Does that make sense? So if I know one angle in a triangle is 80, what do the other two have to add up to be? If I know one angle in a triangle is 80, the other two have to add up to be 100. So if I said I had 40 and 80, and the other triangle has 60 and 80, are they similar? Hell yeah, because the last angle is the same as the other angle in the other triangle. You guys got with me? So if they give me two angles and only one of them is congruent, that doesn't automatically mean they're not similar. They could have just given me the other angle. Okay. Maybe. I'm going to continue to try to use you. Here we go. Okay. What about, okay, 5 again. 5. Yeah, for two reasons. They could have made it a little more interesting. What kind of triangles are those? Equilateral, yeah. They could have made it a little more interesting, but the minute I see 60-60, the last one's got to be 60. Okay, so this one is definitely, so this is nope, and this one is yep. Okay. All right. Who got this one? This one's not horrible. And again, I mentioned this really quickly, but hopefully this makes sense. When I write down the similarity statement, triangle JKL is similar to triangle, oh crap, sorry guys. Oh man, I got excited for a second. I'll stop. I thought he had disappeared. I could never make him disappear. This means that J corresponds to M and K corresponds to N. You guys got it with me? So when you write your similarity statement, you do have to be a little careful. You can't just throw down their names. You have to kind of make sure you have a correspondence in the right way. So do you see how these triangles are rotated from each other? So J, so I would immediately do this. J corresponds to M. K corresponds to N. And L corresponds to P. Now visually I can see a lot better what's going on. How did they take, they took M and P, that poor triangle, just sitting there, not doing anything to anybody. They rotated them and then they shrunk them down, yes? The old rotate and shrink. How much did they rotate them? I don't want an exact answer. They rotate them a lot. No, just barely. They did this, right? So if I just take him, shrink him down, and then just rotate him around, so then that is that. So that's not too bad. That's pretty straightforward to keep track of. Do you also notice, if I do this, if I write the corresponding letters, then JK corresponds to MN. Is that true? JK corresponds to MN. So that's really cool. When you get your homework and you're starting to do it and they give you a similarity statement, they are giving you a ton of information. So let's start off with the easy one. How do you get the measure of angle J? Why is that easy? I wrote over it, but that's a 90-degree angle, yes? And this is a 53-degree angle, so what's that got to be? 37. Kick ass. Just give up on it, Jeff. Okay, I will. Damn it. Should I tape that? It would be the first time in my life I should. I agree. I'm going to do that because I like those glasses. These are too strong, so I'm like, what the? I got to be right up on it. All right, let me see. What was I just saying? Measure of angle J is going to be 180 minus those, so that would be 37 degrees. I like it. Kick ass. When you have a 90-degree angle, that makes a lot of things easier. What about the measure of angle N? I mean, what does it line up with? What angle is it congruent to? K, and K is a 90. Okay. And then the measure of angle P, and of course it lines up directly with L, which is 53. All right, cool. Is everybody with this? This isn't supposed to be overly taxing, necessarily. Obviously, the homework is going to, every now and again, make it taxing. You guys know this. But the basic idea is very straightforward, especially if you're able to identify the correspondence. Because you know they're going to rotate the triangles, they're going to live inside of each other, all kind of weird shit. MP. Now, in order to find these, what should I really find first? If I find this first, it makes side questions easier. Scale factor. And what's the scale factor? Why? No way. Okay. Yeah, if I rotate that to the 4 and the 8 line up, so those must be, one must be the other one ramped up. So to go from JKL to MNP, I gotta multiply by 2. Kick ass. So therefore, what's MP? Because what side does it line up with? Lines up with 5, right? So therefore, MP is, holy shit, 10. And PN is just double what? Double 3, so you get 6. Yeah. And of course, we've seen 3, 4, 5 triangle before, yeah? The 90-degree 3, 4, 5. So anything that is a multiple of 3, 4, 5 is also going to be a right triangle. Kick ass. Kick ass. And by the way, if you ever have to do a standardized test, whenever they do the section with triangles in it, very often they love freaking 3, 4, 5. There's also 5, 12, 13. So it's actually not a bad idea to go in knowing some sides of right triangles that are nice whole numbers. There's not well, there's an infinite number of them, but compared to the ones that aren't, it's a smaller infinity. Whatever, Jeff. Okay. This one, though, what do you guys think about number 8? Does anyone think they got number 8? What did you guys try on number 8? Anybody? Did anybody try anything on number 8? Did anybody do number 8? You guys could just go, oh, I didn't realize you assigned that one, Jeff. That would be, try it. It's not going to work. I think it's not credit to it. You only know one angle for sure. Do you know, and you got to be really careful about which triangles you're talking about. You're talking about triangle ABC, the big one, and BBC, the right part. Yes? So they don't give a shit about the other poor little triangle. Do you know, let's see. Let's point out a couple things and then we'll head out and finish this up next time. But if I give these some names, just so I can reference them easier, I'm going to call this one X, I'm going to call this one Y, this one Z, and then everybody else I think is pretty good. Yeah. This is angle A, that's angle C. And this whole thing we'll call, if everybody's cool with it, we'll just call this whole thing here B. Yes? Oh, one more, Jeff. We'll call this one, you could do it, buddy. W, sure. Okay. What's true about Z plus W? 180. Cool. So Z plus W is 180. That's one good thing to know. X plus Z plus angle A is, so if I start writing some stuff down, X plus Z plus angle A, what would that be? 180. Y plus W plus angle C is 180, yes? Z plus W is 180, yes? I'm just kind of gathering a bunch of things that I can see are true. Oh, and of course the big one, angle A plus angle B plus angle C is 180 on that big ass triangle. So what I need to show similarity is either all the sides are the same length, and I don't have a freaking clue about any sides, right? Side BD is in both little triangles, but I don't care about the poor little left-sided little triangle. You guys see what I'm saying? That's not a part of what they asked me about. So to show two triangles are similar, I must show either all the angles are the same, right? Or I must show two sets of sides are ratios, and the angle between is the same. Or I must show, well, I got to show at least two angles are the same between the two triangles. Yes?
Well, technically, they already tell you that.
Yeah, they tell me that.
Well, basically, where it says that they're similar, it uses angle E on both of them and angle C on both.
Oh, no, be careful. This statement here.
No, the bottom one, the other one.
How do you know? Yeah, oh, yeah, you can use that as help. They're saying that A should go to B, B should go to C, and C should go to D. So they're kind of telling you how they should rotate, so you can use that as a hint. Yeah. Okay, so let's do this. We'll call it because that's class time. Next time we'll start with Alan. Next time we'll finish this up, and then we'll get into section 14.3. So make sure if you have them, bring your kits. How many of you guys don't have a compass in your kit? Did I give compasses to everybody that didn't have one? Okay. Oh, you need one? And you need one? Okay. I have enough in one of those cabinets. So we'll play with those next time. We'll see if everybody can keep from poking themselves and drawing one. That'd be good. This is not a nursing. Alright guys, I'll see you next time. Here come the lights.